Welcome to our third screencast on objects and classes. Today we'll be talking about extending classes, hierarchies, class hierarchies, referring to this instance and the parent class of classes and class hierarchies. So first off, we want to talk about how to extend an existing class. So first off, Java allows us to extend an existing class. We can make a subclass of something that already exists. And the way we do it is we declare a public class, the subclass names, and we use the keyword extends, and then we give the existing class name. So we would do something like public class foo extends bar, so foo would be a subclass of bar. So let's do a concrete example from last screencast. We had hands, so we want to give a blackjack example. So we have a class, public blackjack hand, that extends the hand, and as you recall, a hand is like a card game hand. It has a bunch of cards in it, and so we want to actually create a subclass of hand that knows about blackjack. And so what we do is we're going to add the additional things that hand doesn't have that specifically blackjack hands have. So we're going to add a method that returns the blackjack value for this hand, and since it returns an int, we need to create an int to the value, or val, and we're going to return val when we're done calculating what the blackjack hand value for this is. So, first off, we get the number of cards, and we call getCardCount. That method is in the hand class, and so we can just call any of the parent class's methods. So this is a method on hand that returns the number of cards in the hand, and then we want to have a Boolean variable that determines whether or not we have an ace in our hand, because aces can be either value of 1 or 11, so we need to be able to make sure we choose the right value that we want to use for our hand if we have an ace in it. And then we want to loop over all the cards in our hand, and so we go from I to 0 as I list them cards. We then call getCard, which is another method on hand that returns a card at the position I. So we get the card, we then call cards getValue to get the numerical value of the card, and aces are 1, 10s are 10, jacks are 11, queens are 12, and kings are 13. So if the card value is over 10, in blackjack, all face cards are worth 10, so we set the card value to 10. If the card value is a 1, we indicate that we have an ace in our hand by setting ace to true, and then we just say val equals val plus the card value, so we're adding up the value of our hand for each card. And then the last thing we need to do is check to see if there was an ace in the hand, and we can add 10 to the value, and it's less than or equal to 21, then we want to add that 10. We want to make that ace count as 11 and not 1. So if there's an ace and we can consider that ace to be 11, we will do that by adding 10 more to the value, and then we return value, or val. So now we have the blackjack value for this blackjack hand, which is not something we would want to put into hand, because what if we're playing something like poker? Having the blackjack value in a poker hand doesn't make any sense. So we want to make it specifically to blackjack hands. So we're adding this extra behavior to a new class that is an extension of hand. And so we just, again, public class blackjack hand extends hand, we provide any additional behavior that we want, and then we've extended the class hand, and we have a new class blackjack hand. Now, when we did this, that raises the additional access specifier. We previously talked about public, none, and private. There's a new access level that's just with subclasses. So, and it's called protected. So if you make your member variable protected, it's usable only by that class and any subclass of your class. If you make it private, it's only usable by my class. Subclasses can't use it, no one else can use it. If it's public, it's usable by everybody. So we add this new, Java has this protected that allows you to restrict it to your class and any subclasses. And so that's a nice way of making it so that member variables are useful or usable by your subclasses and not usable by everybody. So it's a nice feature in Java. So let's look at some inheritance hierarchy. You have the public class B extends A, so you have the concept of class A as the superclass, class B is a subclass. We make another class C that extends A, so now B and C are sibling classes. They're not related to each other other than they're both subclasses of A. And then we can create a class D that extends C, and now D is a subclass of C, which is a subclass of A, so D is also a subclass of A, but is not related in any way to the subclass of B. So you could build up these huge hierarchies of classes and use them, and all the methods in A are in B and C and D, and all the methods in C are also in D. So that's what Java does to build these class hierarchies, and basically you call that inheritance. The B inherits from A. So let's give an example of more concrete example. We have the superclass vehicle. It has an integer registration number, a person who's the owner, and a method called transfer ownership, which changes the owner to the new owner. When we say class car extends vehicle, we add its own member variable of number of doors. So the car gets all the stuff from the parent, but it also adds the feature of number of doors, so you want to know how many doors are in your car. The truck extends vehicle, and it has a member variable for number of axles, but it doesn't have a member for the number of doors. And the motorcycle, same thing. It has a Boolean that says whether or not it has a sidecar, but it doesn't have any doors because motorcycles don't have any doors, and it doesn't really have any axles, so it's got its own thing. So now we've got 4 classes, 3 of them are subclasses of vehicle. So how do we access to the superclass, and how can we get to the member variables from our superclass? Well, let's create a car, my car. So we can say mycar.owner, and because owner wasn't private in the vehicle, it's accessible by any subclass. And you can also get the registration number because it was also not private in the superclass. I was saying if you made it private, they're not accessible to anybody outside the class. So that's why we would generally want to either make them with none so that they're in the same package, or make them protected so that they're available to our subclasses. So also instances can access the parents or the superclasses methods. So we create a new person, Fred, and then we can transfer my car's ownership to Fred. So that would mean Fred is now the owner of my car. So that's calling the vehicle's transfer ownership method on my car. And because we are subclass, we can do that. So now we talked about having a variable. What about the differences of vehicle, my vehicle, which is a variable of type vehicle, and we can assign it a variable whose type is car. So my car is of type car, but since car is a subclass of vehicle, we can assign that variable into a variable of a parent class or a superclass variable. We can also just directly say my vehicle 2 is equal to the new car. So we didn't construct a vehicle, we constructed a car, but since car is a subclass, we can assign it to the superclass. You can check the type of any object by calling instance of. It's a very nice function or feature of Java. So, and it returns a Boolean, so you can say my vehicle, which is a variable, is an instance of car. If my vehicle is an instance of car, that will return true, and in this case, my vehicle is pointing to my car, which is a instance of car, so it is true. Now you can't do the reverse. You cannot assign a subclass variable to a superclass variable. So because all cars are vehicles based upon subclasses, but not all vehicles are cars. So in this example, my car is of type car, my vehicle is of type vehicle, and so you cannot assign a vehicle to my car, because what if my vehicle is pointing at a motorcycle? You can't assign a motorcycle to a car. So that is not, you can't do the subclass variable to a superclass variable. You can only do the vice versa. Now you can cast typecasting, we talked about typecasting with the primitives, with casting doubles to ints. We can do the same thing with objects, but you must be very careful, because if we're going to take this example of, we have a vehicle called my vehicle, we can print out my vehicle registration number, because registration number is associated with the vehicle superclass, and then we can write the if statement. If my vehicle is an instance of a car, then we know we can safely cast my vehicle to a car, so we have a new car variable C, and we cast my vehicle and assign it to C. So now that we have a variable type car, we can refer to the number of doors in C. We can't call number of doors on my vehicle because it's of type my vehicle, or excuse me, my vehicle. But by casting it, we can now access the member variable in the car, and we know that my vehicle is pointing to a car by using the instance of. Else, if my vehicle is an instance of truck, we can cast my vehicle into a new truck variable, and then we have a truck variable, we can refer to the number of axles, and we could do another else if my vehicle is an instance of a motorcycle, we can cast my vehicle into a motorcycle, and then refer to the motorcycle variable and see whether or not it has a sidecar. So as long as we're in that if, and we know that the thing it's pointing to really is a car, then we can cast it safely. If we tried to cast it to a truck in there, we would get a class cast exception thrown, because you can't cast a truck into a car. And so polymorphism is another concept with class hierarchies. And the idea is that in the parent class, we have our shape. It has a color. It's got a method set color, so we can set the color on this class, this shape, and then we call redraw. And the redraw method is in the parent class, because we need to have the concept of redrawing it. But there's a real sort of, what do we do? How do we know what to draw? But we know we want to redraw the shape, and we want to have that functionality for all our subclasses. So if we create a class rectangle that extends shape, and we override the redraw method and actually draw the rectangle, then we're successfully, we now have a thing that will draw a rectangle when redraw is called. An oval, same thing, we extend shape, we override the redraw method, and it will draw the oval, so ovals know how to draw themselves. And round rectangles, a rectangle with rounded borders, can redraw themselves because they know how to draw themselves. So now we have all the three subclasses actually know how to redraw themselves, whereas the shape is sort of like, well, I'm not sure how do I redraw a shape? So I can then create a list of, or an array of shapes, loop over it, pull out the shape, and call redraw, knowing that all my objects have a redraw method, so this is completely legal, and basically it will work. And the idea is often thought of is that when you call a method on an object, you're sort of sending a message to the object to do something. So you're sending each shape a message to redraw itself. That's one way that people like to think about these, when they say behaviors or messages. When you call a method, it's like that is making it do the behavior, or you're sending in a message to do the behavior. So, and this is all completely legal because shape has a redraw method, and each individual shape will be probably a rectangle or an oval or a round rec or whatever other shapes that are defined, and they all have a redraw method, so everything's hunky-dory, and we'll call the correct redraw on whatever type of shape is in that position in the array. So now the question is an abstract class, and so it sort of goes back to our original thing of what is the right behavior for the redraw method to do in a shape, because a shape is pretty generic. It doesn't necessarily, how many sides does it have? It certainly can have a color. I mean, that seems sad, but the shape might be a triangle, might be a rectangle, it might be a circle, it could be all these things, and we don't really know what it means to redraw that shape, just the generic parent class shape. So basically we really don't want to do anything in the shape because we don't have enough information to be able to do anything. So semantically we don't want to do anything. But we need a redraw method in shape so that we know that all shapes have that redraw method, so that when we have a variable of type shape, we can call the redraw method. And so all the subclasses can override that redraw method. But what's the body of that redraw method? Maybe nothing or something? So Java allows us to have the concept of an abstract class. An abstract class, you have to use the keyword abstract when you're defining the class, but now we can say an abstract method redraw, and so we're saying that this method is abstract. It's not defined, it is a method, it's in shape, but we have no body. We're not going to do any work in shape. So we can still subclass shape, but we must implement or override the redraw, which we've already done. But since it's abstract, and we've had to say it was abstract class and an abstract method, it's now illegal to try to create just a shape object. If you say new shape, that is illegal because it's abstract and cannot actually be constructed. You can't create a generic shape object. Now you can create all the subclasses because they actually have a body for their redraw methods, and those non-abstract classes are often called concrete classes because we can actually construct one and use it. So this is a powerful concept that you might have an abstract base class that can't actually be instantiated, but all the subclasses actually implement the bodies for those abstract methods, and now excuse me, you can create instances of the concrete subclasses. So we're going to talk about another feature in Java. So recall back to static variables, you refer to them by saying class name dot variable name. Static methods, the same thing, you say class name dot method name. Now what if I want to refer to an instance variable? How do I refer to the instance's variable? Well, we use the keyword this, and then we can say the variable name. So example, we have a public class student, we have a private member instance variable, private member variable, instance variable name, and in the constructor, we take a string called name. Now we have two variables of type name, or we have a parameter called name, and we want to assign it to the instance's instance variable name. So we use the keyword this, which refers to this instance's member variable name equals the parameter name. Now you can't modify this, so you can't say this equals something. So that's the one thing, but this will always refer to this instance. So you can even call methods using this. You could say this dot get size or this dot get name, but that's sort of redundant because in the class, if you just say get name, you're implicitly saying referring to this instance's name. So it's implicitly this dot. You don't need to include the this period, and when you call a member an instance method. So there's another special variable that allows you to refer to the parent class, and you could use it for calling parent methods because you don't have any. Well, let's say for example we have a graphical dice that extends parent dice, and we want to override the roll method to add the additional functionality of redrawing the graphical dice. We want to show them on the screen somehow. Well, but when we call roll, we want to actually call the pair of dice's roll method, and in order to do that, we use the special keyword super. So we say super.roll, which calls our parent class's roll method, which will change the value of the two dice, and then we redraw, which will do the graphical part of the thing. So in order to gain access to our parent class's method, we use the keyword super. Methods, we can call any of the parent class's methods by calling super.roll, or super.the method name, excuse me. So we also want to be able to do the work of a parent class constructor, but constructors are not inherited because they're just the description of how to build the object. So that's part of the class and not part of the subclass. So how do we call the parent class constructor? We use, again, the keyword super, but instead of using the super, we're going to use it as a method. So example, here we have the graphical dice default constructor. It calls super with the value 3 and 4, and if you recall from our pair of dice class, it takes two ints which set the value of the two die. So this is calling the pair of dice constructor that takes two ints to set up the two values of die 1 and die 2. And now we can initialize the graphics and then the rest of the, so we've now created our graphical dice instance, and we've used the pair of dice constructor to initialize the value of the dice. So that's a very powerful way to be able to access the constructor from your parent class without, because you don't inherit them normally. You don't get a graphical dice int constructor unless you write one. So you can call super to call the parent classes constructors. And you can actually use other constructors in your class. So, but how do we refer to them? It's similar to the super, where we had it's a variable, or it can be a method. Well, we can use this to refer to other constructors in this instance. So, for example, we have a public mosaic panel that takes int row, int column, int block width, several other ints, a color, and a border width. But we have another constructor that doesn't have the color or the border width. And how do we initialize this? Use this. We could call it this. We supply the row, the column, the block width, the block height, and we supply a color, null, and a border width of 0. So we're calling the first constructor to initialize our mosaic panel, and we're not supplying a color, and we're saying the border width is 0 because this constructor doesn't have a color. So that we can use this again as a method call, and that will call the other constructors in this class. So that's similar to using super to call the constructor from a parent class. We can use this to call other constructors in this class. And that is all for today. So hope you enjoyed this.